Chapter 10H, we're focusing on area of composite shapes. This is just your do now activities, so it is your DNA. So let's just get started. Find the perimeter of the sector if A equals 120 degrees, R equals 4 kilometers. So we're just going to be applying our formula. So in this case, it'll be P equals to A over 360 times 2 pi R plus 2R. Substitute the numbers in. Type this exactly in your calculator. What is it? 7, 4. It's my number 16.38. For my second one, do the same thing. There we go. Do the two solutions right here. Now, the learning aim for this unit is that we're going to learn what composite shapes are and how to find their areas, okay? Hopefully by the end of this video, you can explain what a composite shape is, you can break a composite shape into simple shapes, and you can calculate the areas of composite shapes. So first of all, what are they? They are just made up of more than one simple shape, okay? It's found by either adding or subtracting the areas of simple shapes. So in this case right here, in my first example, I got a square and a triangle. So if I were to draw these two separately, as you can see, they just combine together. So it just becomes that weird shape, whatever it is that the diagram that they've got there. Okay. Now, in my second example, I got a rectangle here, and then I got a triangle here. Oops, I drew this wrong. So subtract that, and that's what gives me this. Just like that, okay? So it's like a big rectangle, and I break off a piece of a small triangle. That's it. And this shaded area is the area. So describe where you would draw a dotted line to divide these shapes up into two or more simple shapes. So basically you're just drawing dotted lines. So you're trying to spot where the simple shapes are. Okay. So over here, I can sort of draw a dotted line here. So this will give me a rectangle and a triangle. That's fine. Over here, I can do the same thing. Split this off. Or another variation is I can do this instead. I can do variation 1 or I could do variation 2. I probably won't do orange. I'll do a different color. Do black. So as you can see, there's many different iterations that you can make, but just stick with what you know, okay? So you can do something like this. Or what you can do is you can break this up into more. So as you can see, it's like that. So variation 1, or you can do variation 2. The main difference is variation 1 is when you have to add, And then variation 2 is where you're forced to subtract. That's how it works here. Over here, decide if the easiest method is adding two shapes together or subtracting one shape from another. So keyword, adding two shapes together or subtracting one from another. In my case, for the first one, it's actually easier to add because I can do triangle plus square. In my second one, it's actually easier to subtract because rectangle minus square. And in my final one, it's actually easier to subtract as well because rectangle minus triangle, like so. Alright, the first example mainly focuses on addition, so just make sure you highlight the word addition here. What I'm going to do, step one, is I'm going to break this weird shape up into easier ones that I can work with. So just like this. So I can break this up into a rectangle and a triangle. I now need to find the area of both of these. Okay, so for number one, I've got a rectangle here. What I'll do, just to make it a bit easier, is I'll do area of rectangle equals length times width, because this is the formula. The length of the rectangle is 9 meters, and then the width of it is 5 meters. This just equals to 45. It's nice and simple. Now, in my second diagram, I have a triangle here. The formula is base times height divided by 2. But the thing is, like, we don't know what either of those are. So you have to do some reasoning here. If you have a look here, I've got this listed here as 12 meters. This 12 meters is actually the length of the whole thing here. This whole line. I'll make it meter. So that's 12 meters. But as you can see, 9 meters stop at this point right here. That means the remaining amount from purple would just be 12 minus 9, which is 3 meters anyway. Great. That's done. Now I need to find the height of this triangle, but that's pretty straightforward because if you have a look on the left side here, on my rectangle, I've got a width of 5 meters and it's the exact same height. If I were to draw a straight line down, this would just be 5 meters as well. So that means the height of my triangle is 5 meters. So just plug this in. So it becomes 3 times 5 divided by 2 equals to 7.5 meters squared. And then now that we found the area of the two shapes, we can just add the two together. So A total equals 45 plus 7.5, which equals to 52.5 meters squared. Just like so. Now number 2. So question 2 here. Luckily it's already done for us. We just need to find the area now. So we need to find the area of the square. That's pretty straightforward. It's just length times length. Now, thankfully enough, we can tell that it's a square because as you can see here, this line where it's 2 centimeters long, it's got these two double strokes here. And on just right beside it, it also has the same thing. That means this is also 2 centimeters. So we know it's a square. So we can just apply the formula of area of square, which is length times length. So 2 times 2, that equals to 4 centimeters squared. Now we need to find the area of the rectangle underneath it. Just apply our formula, length times width. So we know the length of the rectangle would be 5 centimeters. Because if you have a look here, the distance between that is there. And we're also given the width of the rectangle, which is 2. 5 times 2 is 10. Now we just need to find a total. A total, 10 plus 4, which equals to 14 centimeters squared. That's it. Here you go. I'll give you some time. Figure it out. See if it matches with my one. Alright, here you go. Compare your answers with what I've got. Just make sure that we're showing our working out. Any questions, just reach out. Alright, the next thing is finding the area of composite shapes using subtraction. Okay, so as you can see in my first example here, I've technically got this outline is 6 centimeters. Double stroke here. That means this is also 6 centimeters. This is also 6 centimeters. That means this is a big square. So I've got a square here. So I need to find the area of the square. So that's pretty straightforward. Centimeters squared, just like that. Now, in this area here, shaded in black, as you can see, that is actually a triangle. So, just judging from what I can tell so far, the height of the triangle is 4 centimeters, and the base of it would be 6, okay? So, if you had a look here, so if I were to draw this triangle, and then I flipped it around, it would pretty much look like that, eventually. So that's why I can tell it's a triangle. So A of triangle equals 6 times 4 divided by 2 equals 12 centimeters squared. That means the total area, the one shaded in blue right now, would be 36 minus 12 because I'm taking away the triangle away from the square. So 36 minus 12 equals to 24 centimeters squared, just like so. And that's it. I'll try and squeeze in just a second example in. Just give me one moment. Let me just draw this out. So for number 2, I can see that it's a square as well because as you can see, these two lengths are 7 centimeters. They're equal, so that means I'm given a square. So let's just find the area of the square first. 7 times 7 is 49. Now I need to find the area of said triangle. And this formula is base times height divided by 2. The base of my triangle can be 3 or 4, it doesn't really matter. So 4 times 3 divided by 2. And this just equals to 6 centimeters squared. I'll probably just write it at the bottom. Now the A total, the area total, would just be 49 minus 6, which equals to 43 centimeters squared. And that's it. Right there. So these are questions you got to do. Good luck. If you have any questions, please let me know. Take care.